Here I am giving you the answers of the questions given in the mock test 4 held on today on 3rd June 2022. Total number of questions given was 45 and time allotted for your answer was 45 minutes. Now let us take the first question. It's a question from kinematics. What does it say? A particle located at x equals to 0 at time t equals to 0 starts moving along the positive x direction with a velocity v that varies as v equals to alpha root x. The displacement of the particle varies with time as. That's the question. Now, the given condition is that v equals to alpha root x. So, v is a variable and we are to find the relation between x and t. So, we have to apply calculus. V equals to dx dt equals to alpha root x. Now, let us take the process of separation of variables. Then dx by root x equals to alpha into dt. Now, we have to integrate to get the relation between x and t, that is the displacement and the time, where x varies from 0 to x and time varies from 0 to t. So 1 by root x into dx, integration of it gives you 2 root x equals to alpha into t. So x equals to 1/4 alpha square t square. So x varies as t square. So B is the correct option. So the correct answer of the question number 1 is B. Now let us take the second question. What does it say? Let us see it. A body traveling along a straight line traversed 1/3 of total distance with a velocity v1. So total distance, 1/3 of total distance, let the total distance be 3x. So 1/3 of total distance is x and it traverses this distance with a velocity v1. The remaining part of the distance was covered with a velocity v2 for half the time and with velocity v3 for half the time. So there are two half times. So let us take the time of the latter part is twice t. Then it covers a distance for time t with velocity v2 and for the next time t it traverses with velocity v3. So the distance, that is 2x, is actually covered first one for the time t with velocity v2 and for the next this is with velocity v3. So twice x equals to v2t plus v3t. What to calculate the mean velocity averaged over the whole time of motion? Mean velocity, average speed actually. That v average equals to total distance traversed. Total distance is 3x by time taken. For the first part, the particle traverses a distance or body traverses a distance x with velocity v1. So the time taken is x by v1. And for the next two part, time taken is t for each part. So total time is twice t. Now let us calculate t in terms of x from the equation for the rest part of the motion. For the last twice x distance, twice x equals to v2t plus v3t. Hence t equals to twice x by v2 plus v3. Now let us put the value of t in the equation 1. That gives us thrice x by v1 plus 2 into t, that is 4x by v2 plus v3. So after simplification we will get 3v1 into v2 plus v3 by v2 plus v3 plus 4v1 plus 4v1. So the correct answer is 3v1 into v2 plus v3 by 4v1 plus v2 plus v3. B is the correct option. So the correct answer to the question number 2 is B. Now Let us see the third question. A body starts from rest with uniform acceleration. The velocity of the body after time t is v. So when the body starts from rest, the velocity after time t is v. So v equals to a into t, where a is the uniform acceleration. The displacement of the body in the last 3 seconds. Let the body travels for t seconds. So the displacement for the last 3 seconds, s3 equals to s of time t minus s of time t minus 3. That is your s equals to ut plus half at square. So that is, it starts from rest. So u is 0. So that is half a into t square minus half a into t minus 3 whole square. That is your half a. If you take half a common, then you will take t square minus t minus 3 whole square. That is in the form a square minus b square. So we will put a plus b, that is twice t minus 3, and a minus b gives you only 3. Now there is no a in the options, so we have to substitute a as v by t. So half a is we put v by t in place of a into twice t minus 3 into 3. So our correct option is put thrice v in the numerator, and twice t inside the bracket. You will get 1 minus 3 by twice t. So thrice v into 1 minus 3 by twice t. Thrice v into 1 minus 3 by twice t. We find this form in the relation C, in the option C. So the correct option for the question number 3 is C. Let us see the fourth question. What does the fourth question say? Actually find that a ball is dropped on the floor from a height of 10 meter. It rebounds to a height 2.5 meter. If the ball is in contact with the floor for 0.01 second, what is the average acceleration? So average acceleration average equals to v2 minus v1 by t. So let us first find that the velocity of the ball when it is in contact with the floor. For the first case, when it is touching the ground, the velocity v1 equals to root over of twice g. It is 10 into h, so that is 10 root 2. And when it is bouncing back, when it rebounds, the velocity v2 equals to root over 2 into g into 2.5, that is root 50, that is your 5 root 2. If the initial velocity was taken as negative, then the final velocity is positive. So the change in velocity is 5 root 2 minus of minus 10 root 2, and time of the ball when it was in contact with the floor was 0.01 second. So the time of rebound is 0.01 second, that is 10 to the power minus 2 seconds. So the average acceleration is 15 root 2 into 100, 1500 into root 2, that is 1.414. Neglecting the latter part to have a easier calculation, we get 2100. 4 into 15, 66, 15 into 6, 21. 2100. So correct option is C. So the answer of the question number 4 is C. Now let us see the question number 5. It's a question from vector algebra. The sum of two forces acting at a point is 16 Newton. If the resultant force is 8 Newton, then the direction, and its direction is perpendicular to the smaller force, then the forces are. The sum of two forces is 16 Newton. You have two forces, the sum is 16 Newton. And if the resultant force is 8 Newton and its direction is perpendicular to the smaller force. So let us draw the vector diagram. Actually, the forces acting CB and BA, and the resultant is CA. Resultant is 8 Newton, and the two forces, sum total of two forces is 16 Newton. And as the direction of the resultant force is perpendicular to the smaller force, that is CB, so we get a right angle triangle. And we know that 10 square minus 8 square equals to 6 square. So 10 square minus 6 square equals to 8 square. So other two forces are 10 Newton and 6 Newton respectively. 10 plus 6 equals to 16. So we may come to the answer. Correct answer is A. So the correct answer to the question number 5 is A. You may consider that CB is P and BA is 16 minus P, and then you may apply the law of right angle triangle. P square plus 8 square equals to 16 minus P whole square, and you will get the same result. Next, it is also a question from vector algebra. The diagonals of a parallelogram are represented by vectors P and Q. Then the area of the parallelogram. Area of the parallelogram A equals to half of mod of vector P cross Q. Now let us calculate P cross Q vector. P cross Q vector equals to first row I, J, K. Second row for P, 5 minus 4, 3. 5 minus 4, 3. For Q it is 3, 2 minus 1. 3, 2 minus 1. This is equals to I into 4 minus 6 plus J into minus 5 minus 9 plus K into 10 minus plus minus into minus plus into 12, that is your minus 2I minus 14J plus 22K plus 22K. Hence, half of mod of P cross Q equals to half into root over of 2 square plus 4 square plus 22 square. That is your half into 2 square means 4 plus 16 plus 484 equals to half into root over of 484, 500, 14 into 14 square, this is 196, 200, 684. If you put 2 within the root as 4, then you will get root 171. So the correct answer is A. Correct choice of the question number 6 is A. Now let us see the question number 7. This question is also from vector algebra. For any two vectors A and B, if A dot B equals to mod of A cross B, the magnitude of C equals to A plus B is. Now, we see that A dot B equals to mod of A cross B. So, mod of A cross B divided by A dot B equals to 1. And that is equals to tan theta if the angle in between the two vectors A and B is theta. So tan theta equals to 1, which implies that theta equals to 45 degrees. So the angle in between the two vectors is 45 degrees. Now, from vector additions formula, we may write down C square equals to A square plus B square plus 2AB cos 45 degrees, that is 1 by root 2. So C equals to root over of A square plus B square plus root 2 into AB. So our correct option is D. So correct answer of the question number 7 is D. Now see the question number 8. It is a question from projectile motion. It is a question from projectile motion. A particle is thrown with velocity u, making an angle theta with the vertical. It just crosses the top of two poles, each at height a each after 1 second and 3 seconds respectively, the maximum height of the projectile. When the projectile crosses the two heights at time 1 second and 3 seconds, then the total time of flight is the sum total of these two moments. That is 1 plus 3 seconds equals to 4 seconds. So the time of ascending is 2 seconds and time of descending is 2 seconds. What to calculate? The maximum height of the projectile. So to calculate maximum height, we may calculate the height of descending, and that should be the maximum height. For the descending particle, u equals to 0 at the topmost point. It was momentarily at rest. So it's the horizontal component, its velocity was just horizontal, so the vertical component of velocity was 0. Now, to calculate the vertical height h, u equals to 0, acceleration g is 9.8, hence h equals to half gt square, g 9.8, and time for descending is 2 seconds, that is 2 square, that is your 19.6 meter. Hence the maximum height of the projectile is 19.6 meter. Now let us consider the question number 9. It is also from projectile motion. A projectile is thrown with an initial velocity ai plus bj meter per second, where I and j are the unit vectors along horizontal and vertical directions respectively. If the range of projectile is twice the maximum height reached, then we have to find the relation actually in between b and a. We know that if the range of the projectile is n times the maximum height, then tan theta equals to 4 by n. Here, n is actually 2. So tan theta equals to 4 by 2 equals to 2. And initial velocity u equals to ai plus bj. Hence tan theta equals to b by a, all you know. And that is equals to 2. So b equals to 2a. So C is the correct option here. So the correct answer of the question number 9 is C. Now consider the question number 10. The increase in length of a wire on stretching is 0.25%. If its Poisson's ratio is 0.4, then the percentage decrease in diameter. Now, we know the expression for Poisson's ratio, sigma equals to dr by r divided by dl by l. We have to calculate dr by r. So, dr by r equals to sigma into dl by l. Now, sigma equals to 0.4 and percentage increase in length is 0.025%, 25 into 10 to the power minus 3, and when we convert this percent into fraction, then there will be another minus 2, that is 10 to the power minus 5. So this is dr by r in terms of percent. Now we are calculating in terms of fraction. Now it is 10 into 10 to the power minus 5, that is your 10 to the power minus 4. When we convert this into percentage, we have to multiply it by 100, that is 10 to the power minus 4 into 10 to the power minus 2, that is 0.01%. That should be our correct answer. So the correct choice for the question number 10 is A. Now, next question is question number 11. For the question number 11, we see 4 wires of same material are stretched by same load. The dimensions are given below. Which of them will elongate the most? So, let us consider the formula of elongation. We know that y equals to dl by L, f by A divided by dl by L. So, dl equals to fl by ay. Dimensions are given length and diameter in each case. So dl is proportional to actually L by A, means A is the cross-sectional area, that is equals to your pi d square by 4 into y. So dl is proportional to L by d square. So dl will be maximum when L is maximum and d is minimum. And we find it only in option D, where L is maximum and diameter is minimum. So we will get the maximum elongation in option D. So correct answer of question 11 is D. Now let us take the question number 12. The compressibility of water is 6 into 10 to the power minus 10 Newton. If 1 liter is subject to a pressure 4 into 10 to the power 7 Newton per meter square, the decrease in its volume. So compressibility is the reciprocal of the bulk modulus of elasticity. We know that bulk modulus K equals to dP divided by dV by V. So compressibility 1 by K equals to dV by V whole divided by dP. Their compressibility is given and it is 6 into 10 to the power minus 10. So 1 by K is 6 into 10 to the power minus 10. Pressure is given. Decrease in its volume, we have to calculate the decrease in its volume. So we have to calculate dV by V. V is 1 liter. We have to put 1 liter equals to 1000 cc. And dP. dP is 4 into 10 to the power minus 7 Newton per meter square. 4 into 10 to the power 7. When V is in cc, we will get dV also in cc. So dV equals to 6 into 4 into 10 to the power minus 10, and here 10 to the power 3 into 10 to the power 7 means into 10 to the power 10. That is your 24 cc. So the correct option is B. Correct answer to the question number 12 is B. Now let us consider the question number 13. In question number 13, we see that a wire of length L is hanging from a fixed support. The length changes to L1 and L2 when masses M1 and M2 are suspended respectively from its free end. Then L equals to. We know that when mass M1 is hanging, then weight M1G equals to Kx. X is the extension in length, that is L1 minus L. So also for mass M2, weight Mg equals to K into L2 minus L. What to do? We have to calculate L. Now divide equation 1 by equation 2, K will cancel out. And G is also cancel out here. So M1 L2 minus M1 L equals to M2 L1 minus M2 L. To calculate M2, take M2L to the left hand side. To take M2L, now M2L1 minus M2L, here M1L2 minus M1L. So M2L to the left hand side, its sign will be now positive M2 minus M1 into L equals to M2L1 minus M1L2. So L equals to M2L1 minus M1L2 by M2 minus M1. Find this in option number D. So correct answer of the question 13 is D. Now let us take the question number 14. It is a terminal velocity related problem. The terminal speed of a sphere of ball density 19.5 kilogram per meter cube is 0.2 meter per second in a viscous liquid of density 1.5 kilogram per meter cube. Then the terminal velocity of a sphere of silver density 10.5 kilogram per meter cube of the same size in the same liquid. We know that the expression for terminal velocity Vt equals to 2 by 9 eta r square rho minus sigma into g. So Vt is proportional to rho minus sigma. That is, it is proportional to the difference in density of the material of the sphere and the difference of the medium, corresponding medium, if r and eta are constant. Now, in the first case, we see that Vt is 0.2 equals to k into, what is the value of rho? Rho is 19.5 and sigma is 1.5. So put it here, 19.5 minus 1.5. We get the equation number 1. Now, in the second case, let the terminal velocity be v equals to k into density of silver is 10.5. Density of silver is 10.5. So it is 10.5 minus density of the medium 1.5. So divide equation 2 by 1, we get v by 0.2 equals to k into what? 9 by k into 18. That is your half. So v equals to 0.2 by 2 equals to 0.1. So the answer is 0.1 meter per second. So our choice for the question number 14 is A. Now let us take the question number 15. In this question, we see a metal block of area 0.1 meter square is connected to a 0.01 kg mass via a string that passes over an ideal pulley considered massless and frictionless as shown in figure. Here a block of area 0.1 meter square is connected to a 0.01 kg mass by a ideal pulley and by a string which passes over an ideal pulley. A liquid with a film thickness 0.03 millimeter. Film thickness is 0.03 millimeter. Is placed between the block and the table. When released, the block moves to the right with a constant speed. When it is moving with a constant speed, there is no unbalanced force. The coefficient of viscosity of the liquid. Now, what forces are acting? Now, the weight of the that is the weight of the mass, is acting in the downward direction. And tensile force will nullify for the whole system. So, another external force, that is the viscous force, is acting. Viscous force is acting. So, viscous force equals to weight of the mass. And we know that viscous force F equals to eta A dV dx. Eta A dV dx equals to, for the mass, corresponding weight is mg. Now, we have to calculate the coefficient of viscosity. So, we have to calculate eta. So, eta is here. What is the value of A? A is 0.1 meter square. dV. Velocity difference is 0.085 meter per second. That is your 85 into 10 to the power minus 3. What is dx? Dx is 0.03 millimeter. But we have to convert it in SI unit, that is in meter. So it is already 3 into 10 to the power minus 2 millimeter into 10 to the 0.3 millimeter. So that is 3 into 10 to the minus 1 millimeter into 10 to the power minus 3 meter. That is your 3 into 10 to the power minus 4 meter. 3 into 10 to the power minus 4 meter equals to m, that is 10 to the power minus 2 into g. We have to take g as 9.8. So, there is a calculation for you. 10 to the power minus 2 into 9.8 into 3 into 10 to the power minus 4 whole divided by 85 into 10 to the power minus 4. So, 10 to the power minus 4 should be cancelled out. So, here we have to calculate the value of eta, that is 29.4 by 85 into 10 to the power minus 2. So this should be into 10 to the power minus 3, 255, 39, 390 into 4, 340, 3.45 into 10 to the power minus 3 Pascal second. 3.45. So B is the correct answer. So the correct answer option for the question number 15 is B. Question number 15 is B. Let us see the next problem. It is also a terminal velocity related problem. Actually, the topic is too much important for your examination. So there are two questions from the terminal velocity. A metallic sphere of mass m falls through a glycerine with a terminal velocity v. If we drop a ball of mass 8m of same metal into a column of glycerine, the terminal velocity of the ball will be. So here is a problem. The relation, we have to find the relation in between mass of the ball and the terminal velocity. So we have to start from mass. Mass m equals to 4/3 pi r cube into rho, as it is a spherical ball. In the second case, mass is 8m. That is also your 4/3 pi r1 cube into rho, as they are made of same material. So dividing it, we get 1/8 equals to r by r1 cube, r by r1 whole cube. So r by r1 equals to half. So r1 equals to twice r. So the radius of the ball is twice. We know that terminal velocity Vt is proportional to r square, radius square. So now the radius is twice, so the terminal velocity will be 4 times. So correct option is B. So correct option to the question number 16 is B. Now we consider the question number 17. In question number 17, we see that a drop of liquid of diameter 2.8 millimeter breaks off into 125 identical drops. The change in energy is nearly equals to. Change in energy equals to change in surface area into surface tension. Change in surface area delta A into T. So let us take the diameter of the first ball as D, and it splits into 125 identical drops. So the volume remains same in case of such splitting. So volume of the first ball 4/3 pi into 2.8 into 10 to the power minus 3, we are taking it, we may take it in centimeter, that is 10 to the power minus 1 by 2 whole cube. Volume of the bigger ball equals to volume of the smaller balls, total volume 4/3 pi r cube into 125. So 4/3 pi will cancel out from each side. Here 1.4 into 10 to the power minus 1 equals to 5r. So r equals to 1.4 by 5 into 10 to the power minus 1. That is your 2.8 into 10 to the power minus 2. Now, change in surface area. For the 125 smaller balls, surface area is 125 into 4 into pi into 2.8 into 10 to the power minus 2 whole square, minus surface area of the bigger ball 4 pi into r square, that is your 1.4 into 10 to the power minus 1 whole square, that is your 4 pi into 125 into 4 pi 125 into 2.8 into 2.8, 7.84 into 10 to the power minus 4 minus 1.96 into 10 to the power minus 2. So our calculation meticulous calculation will give us 4 pi into 125 into 7.84 into 10 to the power minus 4, 1.25 into 7.84 into 10 to the power minus 2 minus 1.96 into 10 to the power minus 2. That is 4 pi into 5 by 4, this is 4, 19, 6, 1.96 into 5, 1.96, take it this factor out of the bracket, 1.96 into 10 to the power minus 2, 5 minus 1, that is your 4. So 4 into 22 over 7 into 1.96 into 10 to the power minus 2 into 4. 7, 2, 8, 28 into 10 to the power minus 2 into 10 to the minus 2. 28, 616 into 4 into 4 into 10 to the power minus 4 equals to 616 into 16 into 10 to the power minus 4 equals to 6.16 into 0.16. Nearly. This calculation will give us 6.16 into 10 to the minus 6. So it will nearly gives us 74, nearly. So correct option is D. So the correct option to the question number 17 is D. Now let us consider the question number 18. In this question we see a soap film of a rectangular frame of wire area 4 by 4 centimeter square. If the area of the soap film is increased to 4 by 5 centimeter square, the work done in this process. So the change in area 4 by 5 to 4 by 4 is 4 into 5 minus 4 into 4. But for the soap film there are two surfaces. So to calculate the change in surface area, we have to multiply this factor by 2. This is equals to 20 minus 16, 4 into 2. That is your 8. We have to multiply this factor by 3 into 10 to the minus 2. But the change in surface area is actually given in centimeter square. So in meter square it is 8 into 10 to the power minus 4. So work done is delta A into S, that is 8 into 10 to the power minus 4 into 3 into 10 to the power minus 2. That is your 24 into 10 to the power minus 6 joule. So correct option is B. So correct answer of question number 18 is B. Now let us consider the question number 19. Our next question is question number 19. An ideal gas is expanding such that Pt square equals to constant, the coefficient of volume expansion of the gas. We know that coefficient of volume expansion is 1 by V into dV dt. So we have to change P in terms of V in the given form Pt square equals to constant, because our needed expression, needed quantity is 1 by V dV dt. So convert P in terms of V. We know that PV equals to RT. So P equals to RT by V. So RT by V into T square equals to constant, which gives us T cube by V equals to another constant C1, that is C by R. Taking log of both sides, 3 ln T minus ln V equals to ln C1. Now differentiating 3 by T into dt minus 1 by V into dV equals to 0, as log C1 is a constant. So we get dV divided by V into dt equals to 3 by T. So our correct option is C. So correct answer of the question number 19 is C. Now C, let us consider the question number 20. In question number 20, we see that the volume of a metal sphere increased by 0.244 percent when its temperature is raised by 40 degrees centigrade, the coefficient of linear expansion of the metal. We have to calculate the coefficient of linear expansion of the metal. First of all, we will calculate the volume expansion, and next we will get the linear expansion easily. So, volume expansion coefficient gamma equals to 1 by V into dV dt. So, here change in volume, that is dV by V, percentage change in volume is given, so the fractional change is 0.24 into 10 to the power minus 2. Now dt is 40 degrees centigrade, the coefficient of linear expansion of the metal. dt is 40, so 0.24, that is your 24 into 10 to the power minus 4 by dt is 40. So that is your 0.6 into 10 to the power minus 4. Now, linear expansion coefficient alpha equals to gamma by 3. So this should be, here gamma equals to 6 into 10 to the power minus 5. So here the answer is 2 into 10 to the power minus 5 per degree centigrade. So the correct answer of the question number 20 is A. So the correct answer of the question number 20 is A. Now we will consider the question number 21. In question number 21, the temperature of 100 gram of water is to be raised from 24 to 90 degrees centigrade by adding steam to it. The mass of the steam required for this purpose. Now, latent heat of condensation is 540 calorie per gram. First, steam at 100 degrees centigrade. Let the mass of the steam is m gram. So, steam will release an amount of heat 540 m to be converted into water. And next, the temperature goes down from 100 degrees centigrade to 90 degrees centigrade. So there is a consideration of further release of heat, and this should be m into 1 into 100 minus 90 equals to 10. What is done? Actually, the temperature of 100 gram of water is to be raised from 24 degrees centigrade to 90 degrees centigrade. So the sensible heat required is m. M is what? 100 gram. S is 1. Specific heat of water is 1. And temperature raised from 24 degrees centigrade to 90 degrees centigrade, that is your 66. So left hand side gives 540 m plus 10 m, that is your 550 m equals to 6600. So m equals to 6600 by 550 11 5 65 into 12. So m is 12. So the correct answer is 12. Our correct option for the question number 21 is B. So now let us see the question number 22. In this question, there are 3 identical metal rods X, Y, Z are placed end to end, and a temperature difference is maintained between the ends of X and Z. So 3 rods, identical rods, that is, they have identical length and identical cross section. Identical metal rods X, Y, Z are replaced end to end, and the temperature difference is maintained between X and Z. X, Y, Z, temperature difference is maintained between X and Z, that is, they are in series combination. If the thermal conductivity of Y is twice that of Z, thermal conductivity of Y is twice that of Z. Thermal conductivity is Ky of Y, that of X is Kx, and that of Z is Kz. Thermal conductivity of Y is twice that of Z, that is Ky equals to 2 Kz, and half that of X, So that is kx ky equals to kx by 2. Now we know that in series combination, if length of each rod is d, then if the equivalent conductance of the combination is k, then 3d by k equals to d by kx plus d by ky plus d by kz. Now kx equals to 2ky, so d by 2ky plus d by ky, and kz equals to ky by 2. From here it is clear, kz equals to ky by 2, d divided by ky by 2, that is 2d by ky. So HCF is 2ky, here d plus 2d plus 2d by ky, 2ky, so that is 4d. That is your 3d by k equals to 4 plus 2, 7, 6 plus 1, 7d by 2ky. So k equals to 6ky by 7. So our correct answer is 6ky by 7. It is in option B. So the correct option for the question number 22 is B. Now switch over to the question number 23. In question number 23, we see that a cup of tea cools from 65 degrees centigrade to 62 degrees centigrade in 1 minute in a room of 22.5 degrees centigrade. How long will the same cup of tea will take to cool from 46.5 degrees centigrade to 40 degrees centigrade in the same room? This is a problem from Newton's law of cooling, and we have to calculate the time. In this case, Q by T equals to K into theta 1 plus theta 2 by 2 initial and final temperature by 2, that is the average temperature, minus theta 0, where theta 0 is the surroundings temperature. Let the mass of T is m. So, and if the specific heat is S, then Q equals to ms into T, temperature goes down by 3 degrees centigrade, and time taken is 1 minute. So T is 1 minute equals to K, average temperature of 65 degrees centigrade and 62.5 degrees centigrade, 65.5 and 62.5 degrees centigrade. In this case, average temperature is 64 degree and the room temperature is 22.5 degrees centigrade. For the second case, ms, temperature change is 46.5 degrees centigrade to 40.5 degrees centigrade, that is 6 degrees centigrade, by T equals to K into average temperature is 43.5 degrees centigrade, 86, 87, 43.5 minus 22.5 degrees centigrade. Now, dividing the first equation by equation 2, we see that ms into 3 by ms into 6 into T equals to K into 41.5 by K into 21. SS being cancelled out, 3 into 2. So T by 2 equals to K will also be cancelled out, and this is nearly 2. So T nearly equals to 4 seconds. Our correct option is D. The correct option to the question number 23 is D. Now, switch over to the next question. In this question, we see that a copper ball 2 centimeters in radius is heated in a furnace of 320 degrees centigrade. If its emissive power is 0.3, at what rate does it radiate energy? Key, calculate the rate of radiation, radiant energy. We know that energy radiated per second E equals to sigma T to the power 4 according to Stefan law. But this is the energy radiated per unit second per unit area for a perfect black body. For any black body, we have to multiply the right hand side by emissive power epsilon. And energy radiated per second is actually epsilon A into sigma into T to the power 4. Here epsilon, emissive power, is given as 0.3. A, that is the copper ball of radius 2 centimeters. So its surface area is 4 pi into 2 centimeter, but all the answers are given in watt unit. So we have to convert it in meter. That is, radius is 2 into 10 to the power minus 2 meter, that is whole square, into sigma. Sigma is 5.7 into 10 to the power minus 8 watt per meter square per Kelvin to the power 4. And T, what is the value of T? 327 degrees centigrade in Kelvin scale. This is 600 Kelvin. So you have to calculate 600 to the power 4. That is your 0.3 into 4 pi into 4 into 5.7 into 6 into 6, 36 into 36, 1296 into 10 to the power minus 4 minus 8, and here 10 to the power plus 8. So into 10 to the power minus 4. That is your 1.2 pi into 22.8, nearly 23, and we are taking 1296 as 1300 for making calculation easier, into 10 to the power minus 4. That is 1.2 into pi as 3.14, taking it as 3.1 into 23 into 1300 into 10 to the power minus 4. That is your 12 into 3.1, 12, 3 into 12, 36, 37, 3.72 into 23 into 13 into 10 to the power minus 2. That is 3.7 into 3 into 13, 39, 3, 26 into 3, 29, 2.99. Nearly 3.7 into 3, nearly 11. So our correct answer is 11 watt. So the correct option of the question number 24 is C. Now let us consider the question number 25. In question number 25, it is a question from Thermodynamics. An ideal gas is taken through a step A to B, B to C, C to A. A to B, B to C, C to A. If the net heat supplied to the gas is 5 joule, the work done by the gas in the process C to A. Now it is a cyclic process, so the change in total internal energy is 0. So dQ, summation dQ equals to summation dW. Here total dQ is 5 joule, summation dQ is 5. So we have to calculate dW in each step for the first two steps, and it will give the work done in the third step. For the step AB, it is done at a constant pressure. So the work done is P dV, that is P into dV. P is 10 Newton per meter square, and change in volume is 1 meter cube to 2 meter cube, that is 1, that is 10 joule. So for the process AB, it is 10 joule. Next, for the process BC, volume is constant. For the isochoric process, dW2 work done is 0. And now we have to calculate the work done is in CA process plus WCA, because in this case du for a cyclic process total change in internal energy is 0. So WCA equals to 5 minus 10, that is your minus 5 joule. So the correct answer is A. So the correct option of the question number 25 is A. Now see the question number 26. It is also from thermodynamics. 1 mole of an ideal gas expands adiabatically at constant pressure such that its temperature T is proportional to 1 by root V, the value of gamma for the gas. All we know that for the adiabatic change it is PV to the power gamma equals to constant. But the relation given is in between T and V, so you have to replace P. We know that PV equals to RT, so replace P as RT by V. RT by V into V to the power gamma equals to constant. So T into V to the power gamma minus 1 equals to another constant C1. And now, by the condition T into root V equals to constant. So T into V to the power half equals to constant. Comparing these two equations, we may at once write that gamma minus 1 equals to half. So gamma equals to 1 plus half, that is 1.5. So the correct answer is 1.5. So for the question number 26, we find that the correct option is B. Right? Now let us consider the question number 27. In question number 27, actually it is also a question from thermodynamics. What will be the difference in temperature between the top and bottom of a waterfall of height 400 meter, assuming 80% of heat is contained in water? When water is falling, its potential energy is converted into heat, and when it is at a height h, that is the height of the waterfall, its potential energy stored was mgh, and if it were converted into heat, so the amount of heat generated is mgh by j, and out of this heat 80% is contained in water. So the heat contained in water is mgh by j into 80 by 100, and it will increase the temperature of water. So if m gram water is falling, then the heat required to raise the temperature by T degree centigrade is mst. And we have to calculate all the quantities in CGS unit. In this case, that is 80 by 100 means 4 by 5. We have to calculate the temperature difference. That is T. So T equals to, in this case S is actually 1, G equals to 980, H is 400 meter, but we have to put it in CGS unit, 400 into 100 centimeter into 4 by 5 into J means 4.2 into 10 to the power 7. So 98 into 16 into 10 to the power minus 2 by 21, 7, 3, 14. So 14 into 5.33 into 10 to the power minus 2. 14, 3 into 14, 42, 4, carry 4, 42, 4, 46, carry 4 again, 70 into 4, 70 plus 4, actually 74 into 10 to the power minus 2. So the approximate increase in temperature is 0.74, nearly 6 degrees centigrade. So the correct option is C. So the correct answer to the question number 27 is C. Now we will consider the question number 28. It is also from thermodynamics. For your examination, thermodynamics is an important topic. So more questions are given from thermodynamics. A gas is expanded from volume V0 to V0 under 3 different processes as shown in figure. In figure we can see 3 different processes. Process 1 is isobaric process. Process 1 is isobaric. It is taken at the same pressure and volume is increasing, so temperature will increase. So change in internal energy du is positive. So in internal energy will increase. For an ideal gas, internal energy is a function of absolute temperature of the gas, and here volume is increasing, keeping pressure constant, hence temperature will increase, so internal energy will increase. Process 2 is isothermal. In the process 2, if it is an isothermal process, so there is no change in internal energy in the second process. And process 3 is adiabatic, and the volume is increasing. That is adiabatic expansion. In adiabatic expansion, all we know that system performs work at the cost of its internal energy, so internal energy will go down. That is, du is less than 0 in the third case. So, the change in internal energy of the gas in these three processes, we can see that for the first process, change in internal energy is maximum, next in the process 2, and next in the process 3. So, delta U1 is positive, delta U1, delta U2 is 0, and delta U3 is less than 0. So, delta U1 greater than delta U2 is greater than delta U3. So, the correct answer of the question number 28 is A. Now, consider the question number 29. This is a question from thermodynamics. What is the work done by 1 mole of gas during a quasi-static isothermal expansion from an initial volume V to final volume 2V if the equation of state is P into V minus B equals to RT? So the work done by the gas, that is your PdV. And here volume changes from V to twice V, V to twice V. Now P into V minus B equals to RT. So P equals to RT by V minus B. So we have to replace P by RT by V minus B, dV, V to 2V. The integration gives us the result RT ln V minus B, but limit of the integration is V to 2V. That is, we get RT ln 2V minus B by V minus B. So our correct answer is RT ln 2V minus B by V minus B. So A is the correct option. For the correct option for the question number 29 is A. Now let us see the question number 30. It is also a question from thermodynamics. An ideal engine operates in a Carnot cycle between 227 degrees centigrade and 127 degrees centigrade. It absorbs 6 calories of heat at higher temperature. The amount of heat in kilocalorie rejected to the sink. Now, first of all, we will approach through the efficiency expression as temperature of source and sink is given. Efficiency eta equals to 1 minus T2 by T1. T2 127 degrees centigrade, that is your 400 Kelvin. So temperature of the sink, and temperature of the source is 500 Kelvin as it is 227 degrees centigrade. So the ratio is 1 minus 400 by 500. So 1 minus 4 by 5, that is 1 by 5. So eta is 1 by 5. So eta here is 1 by 5. Now we know that eta equals to dq by q1. dw by q1 equals to 1/5. Absorbs 6 kilocalorie of heat. So q1 is given. So dw equals to 6 by 5, that is 1.2 kilocalorie. Now heat rejected to the sink q2 equals to q1 minus dw, that is your 6 minus 1.2, is your 4.2 kilocalorie. 4.8 kilocalorie. 6 minus 1.2, that is your 4.8 kilocalorie. So our correct option is A. Correct option to the question number 30 is A. Now let us see the next question, that is your question number 31. A Carnot engine having an efficiency eta equals to 1 by 10 as heat engine is used as a refrigerator. If the work done on the system is 10 joule, the amount of heat absorbed from the reservoir at lower temperature. We know that Here when it is acting as a refrigerator, the system or the engine operates in the reverse direction. It extracts Q2 amount of heat from the sink and W amount of work being done, Q1 amount of heat being rejected to the source. So the engine will run in the opposite direction. Now eta equals to 1/10 of W by, that is equals to W by Q1. W by Q1. Here, the work done on the system is 10 joule. So W is 10 joule. So eta 1/10 equals to 10 by Q1. So Q1 equals to 100 joule. Q1 equals to 100 joule. W is 10 joule. So Q2 should be 90 joule. 90 joule plus 10 joule equals to 100 joule. So here Q2, energy absorbed from the reservoir at lower temperature, is 90 joule. So correct option to the question number 31 is C. Now let us take the question number 32. A man measures time period of a simple pendulum inside a stationary lift and find a t, that is t equals to twice pi root L by g. If lift starts accelerating with acceleration g by 4 in the upward direction, then the time period of pendulum is. We know that in that case g will be g plus g by 4, that is your 5g by 4. So the time period t1 equals to 2 pi root L divided by 5g by 4. So that is your root over 4 by 5 into t, that is 2 by root 5 into t, twice t by root 5. So correct option is A. So the correct option to the question number 32 is A. Now let us consider the question number 33. Figure shows the shape of a part of a long string in which transverse waves are produced by attaching one end of the string to the tuning fork of frequency 250 Hz. What is the velocity of the wave? When it is attached to a tuning fork of frequency 250 Hz, so the frequency of vibration is here 250 Hz. And from the wave, we see that length of the wave, that is the distance in between the consecutive particle of same phase, is actually, it is 0.1, this is 0.2 for the half wave, 0.3, and for the full wave it is, the distance is 0.4 centimeter, 0.4 centimeter. So lambda wavelength is 0.4 centimeter. Hence V, velocity of the wave, equals to n lambda 250 into 0.4 equals to 100 centimeter per second, that is your 1 meter per second. So the correct option is A. Correct option to the question number 33 is A. Now consider the question number 34. In question number 34, a particle executes S.H.M of type x equals to a sin omega t. It takes time t1 to go from 0 to a by 2. X equals to 0 to x equals to a by 2. Actually the time taken is t by 12, where t is the time period to go from 0 to a by 2. t2 is the time taken. t2 is the time taken to go from x equals to a by 2 to a. We know that time taken to go from a by 2 to a is t by 6. So t1 is to t2 is t by 12 is to t by 6, that is your 6 is to 12 equals to 1 is to 2. So the correct option is B. Correct option to the question number 34 is B. Now let us consider the question number 35. It is also a question from simple harmonic motion. A particle starts oscillating simple harmonically from equilibrium position with time period t. The ratio of kinetic energy and the potential energy. The kinetic energy is half m omega square into a square minus x square. And that of potential energy is half m omega square x square. The particle at time t equals to t by 12, in the previous problem we have seen that at t equals to t by 12 the particle is at a by 2, so x equals to a by 2. So this is half m omega square into a square minus a square by 4 is to half m omega square into a square by 4. That is your half omega square being cancelled out, 3a square by 4 is to a square by 4. That is your 3 is to 1. So the correct option is C. Correct option to the question number 35 is C. Now see the question number 36. In question number 36, we see a whistle emitting a sound of frequency 440 Hz tied to a string of 1.5 meter length and rotated with an angular velocity 20 radian per second in the horizontal plane. The range of frequencies heard by an observer stationed at a larger distance from the whistle will be. Now the whistle is whirling here and the observer is long way from here. When it is at the position A, it is actually going away from the observer. When it is at B, it is approaching towards the observer, and when it is at the position either C or D, the line joining the observer and the source is actually 90 degree to the motion of the source. So at C or D, the frequency will remain unchanged, let it be n. That is your, here 440 Hz is given. So at these two positions, you will hear the sound of 440 Hz. At A, the source is going away, so the frequency is V by V plus Vs into n. And at B, the frequency will be V by V minus Vs into n. In this position, the source is going towards the observer. So it is equals to, here V is given 330 meter per second. And what is the value of Vs? Vs, V equals to omega r. Here omega is given 20 radian per second and r is 1.5 meters. So omega r is 30 meter per second. So in the first case, we will put here 30 into n is 440, and for the second case it is 330 by 330 minus 30 into 440. So in the first case it is 330 by 360 into 440. And in the second case it is 330 by 300 into 440. So 0, 0, 0, 0 being cancelled out, 3 into 11, 484 Hz. In the first case it is 11, 12. So it is 4840 by 12, 403 Hz. So frequency range will be 403 Hz to 484 Hz. It is found in option D. So the correct option to the question number 36 is D. Now consider the question number 37. A train moves towards a stationary observer with speed 34 meter per second. The train sounds a whistle and its frequency registered is nu 1. If the train speed is reduced to 17 meter per second, the frequency registered is nu 2. If the speed of the sound is 340 meter per second, then the ratio nu 1 by nu 2. So nu 1, the train is approaching towards the observer, so the formula is V by V minus Vs into nu. Here V is 340 and in the first case Vs is 34 into nu. That is your 340 by 306 into nu. In the second case, we are to put 17 instead of 34. That is 340 minus 17 into nu. That is your 340 by 323 into nu. So nu 1 by nu 2 equals to 340 by 306 into 323 by 340. 340 being cancelled out, and it will yield 19 by 18. So nu 1 by nu 2 equals to 19 by 18. So the correct option to the question number 37 is D. Now let us see the question number 38. A steel rod 100 centimeter long is clamped at the midpoint. The fundamental frequency of longitudinal vibrations of the rod is 3 kHz. What is the speed of sound in the rod? Now, the rod is vibrating such that it is clamped at the midpoint. So, notes is forming there, and the fundamental frequency of longitudinal vibration is 3 kHz. So, n equals to 3 kHz. The speed of sound, and it is 1 meter long, 100 centimeter long, that is 1 meter long. That is the distance in between the nodes and antinodes is half meter. We know that lambda by 4, distance in between consecutive nodes and antinodes is lambda by 4 equals to half. So lambda equals to 2 meter. So here lambda equals to 2 meter. Lambda equals to 2 meter. We know that V equals to n lambda. N is 3 kilohertz, so 3000 hertz into 2. That is your 6 into 10 to the power 3. V equals to 6 into 10 to the power 3 meter per second. So correct option for the question number 38 is D. Now let us take the question number 39. When two tuning forks, fork 1 and 2, are sounded simultaneously, 4 beats are heard. Now some tape is attached to the prong of the fork 2. When the tuning forks are sounded again, 6 beats are heard. 6 beats per second are heard. If the frequency of the fork 1 is 200 Hz, then what is the original frequency of the fork 2? There are 4 beats. Frequency of the fork 1 was 200 Hz. So the frequency of the second tuning fork is either 204 Hz or 196 Hz. Now a tape is attached to it. So it is now heavier. So it will vibrate with lesser frequency. And then if it will vibrate with lesser frequency from 204, 203 or 202, the beat frequency will reduce. If it were 202, there were only 2 bits frequency. But when the bit frequency is decreasing, the frequency of the second tuning fork should be lower one, that is 196 Hz. So our correct option is 196 Hz. So the correct answer of the question number 39 is A. Now let us see the question number 40. If the length of a stretch string is shortened by 40% and the tension is increased by 44%, then the ratio of the final and initial fundamental frequencies. The fundamental frequency for a stretch string is n equals to 1 by 2L into root over T by M. Now string is shortened by 40%, so its length L2 is 60% of the original length, so L2 equals to 3L by 5. And tension is increased by 44%, so now the tension T2 equals to T into 144 by 100. So the fundamental frequency in the second case, 1/2 into L equals to 3L by 5 in the second case into root over of T into 144 by 100 M. that is your 1 by 2L into 5 by 3 into 12 by 10 into root over T by M. That is your N into 5, 2, 6, N into 2. So the ratio is, final frequency is twice the first one, so the ratio is 2:1. So the correct answer of the question 40 is D. Now let us see the question number 41. In question number 41, an organ pipe closed at one end is excited to support the third overtone. It is found that air in the pipe has how many nodes and antinodes? Those are the options are given in terms of number of nodes and antinodes. For the fundamental tone, we see that there are one node and one antinode. And for the first overtone, we see that there are two antinodes and two nodes. This is for the first overtone. Then for the second overtone, for the second overtone, it will be like that. For the second overtone, one, two, three nodes, 1, 2, 3 antinodes. So for the third overtone, there should be one nodes and one antinodes more than the previous one. So number of nodes 1, 2, 3, 4. Number of antinodes 1, 2, 3, 4. So nodes equals to 4, antinodes equals to 4. So our correct option is D. We find this option in D. So 41 having correct option D. Now let us take the question number 42. Oxygen is 16 times heavier than hydrogen. Equal volumes of hydrogen and oxygen are mixed. The ratio of speed of sound in the mixture. Now we see that the density of oxygen is 16 times. So the mass is 16V plus for hydrogen. If it were one time, then 16V plus 1 into V by total volume is twice V, that is 17 by 2. Whereas in the first case it is 1. We know that velocity of sound, what is the speed of sound? Speed of sound V equals to root over gamma P by rho. So the ratio V is proportional to 1 by rho. In the second case, it is 17 by 2. So the ratio is root over of 1 by root over of 17 by 2. That is root 2 by root 17. So the correct option of the question number 42 is B. Now let us take the question number 43. The stationary wave produced on a string is represented by the equation y equals to 4 sin pi x by 3 cos 40 by t, where x and y are in centimeter and t is in seconds. The distance between two consecutive nodes. Here, comparing this equation with the stationary wave equation, we find that 2 pi x by lambda equals to pi x by 3. So lambda equals to 6. Distance between two consecutive nodes is lambda by 2. So here the distance is 3 centimeters. So the correct option is B. The correct option of the question number 43 is B. Now let us take the last page. Now first question number 44. The bob of a simple pendulum execute S.H.M in water with a time period T. So it is T equals to 2 pi root L by G. While the period of oscillation of the bob is T0 in air, pendulum is in water with a time period T. So T0 equals to 2 pi root L by G. Neglecting frictional force of water and given that the density of the bob is 4/3 into 10 to the power 3 kilogram per meter cube, the relation between T and T0. Now, when there is a case of apparent weight, we will consider the changed G in this case. In this case, weight of the bulb 4/3 into 10 to the power 3, let the volume of the bulb be V into G, minus weight of the liquid displaced 10 to the power 3 into V into G, that is the apparent weight, equals to mass of the bulb 4/3 into 10 to the power 3 into V into G dash, that's the apparent acceleration due to gravity. Now 10 to the power 3 will cancel out, V will also cancel out, so G dash equals to 4/3 G minus G, that is G by 3, divided by 4/3, that is your G by 4. So T equals to 2 pi root L divided by G by 4. So 2 into 2 pi root L by G. 2 pi root L by G means T0, that is your twice T0. So T equals to twice T0. Correct option of the question number 44 is C. Question number 45. Two identical sinusoidal waves, each of amplitude 5 mm with a phase difference pi by 2, are traveling in the same direction in a string. The amplitude of resultant wave is. Two waves with amplitude 5 mm, they are approaching at an angle 90 degree. So the resultant amplitude is 5 square, r square equals to 5 square plus 5 square plus 2 into 5 into 5 into cos 90 means 0. That is r square equals to 50, so r equals to 5 root 2. So the resultant amplitude is 5 root 2 millimeter. So correct option is B. Question number 45 having correct option B. That's the end of our analytical discussion. Now let us see the MCQ type solution. First question having option B correct, second question B, third question having correct option C, fourth question having correct option C, fifth question having correct answer A, sixth question having correct alternative A, 7D, 8B, 9C, 10A, 11D, 12B, 13D, 14A, 15B, 16B, 17D, 18B, 19C, 20A, 21B, 22B, 23D, 24C, 25A, 26B, 27A, 28A, 29A, 30A, 31C, 32A, 33A, 34B, 35C, 36D, 37D, 38D, 39A, 40D, 41D, 42B, 43B, 44C, 45B. Now, our next mock test, that is the mock test 5, and the tentative date of examination is 9 June, and the topics of the exam are laws of motion, work power energy, and geometrical optics, and revision lesson from kinematics, wave and kinetic theory, also bulk properties of matter are included in the syllabus, and total number of questions expected to be 45, and that is the end of this